Good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. My name's Digital Dragon. Hey, Luke. I'm a 3D printing variety streamer here on Twitch. Welcome on in, everybody. Nick 3DP, Mr. Wizix, Pete. Hey, Pete. Welcome on in, everybody. Hey, Pez, how's it going? Yep, Luke time, Luke time. I hope everybody's having a good day. Um, I will tell you, I am glad that I'm at this stage of my day. Been been a little bit of an emotional and traumatic day today. But I'll just say tech industry. If you're following the news in the tech industry, you probably figure it out. A lot of changes going. Um, but yeah, welcome on in, everybody. Everybody's doing well today. DO build, yes, the DO. So there was a couple of things we had gotten to our wiring, and I had made the comment. Yeah, all problems disappear when we stream. Well, yeah, for the most part, they do tend to go away when we. So I'm gonna go over to the full display for now, just so things are a little bit bigger. And we were going through and getting ready to um, get into some more of the wiring, where we start getting into, do the UBEC or the SBEC one, two, all this, and do some crazy wiring. And then it dawned on me, wait, I've got the boards and the wiring's going to be a little different. Couldn't find the diagram. So here's where we find the diagram. On our DO page, if we scroll down to the bottom, we'll see our instructions and our wiring diagram. This is the basic wiring diagram. Once again, we bought the board, so we're going to be using the control and the power board. So if we click on over to the control and the power board, it talks about the different board options. So we're using this option here, which would use a full size 10 channel receiver for our remote. There is an option to use a tiny receiver that we'll see down here in a second. Rat's nest is a requirement. Well, that's what this whole board here takes care of, a ton of different wiring. Like this piece right here is the buck converter. So this takes the place of a UBEC or an SBEC, which basically um, it's a battery eliminator circuit. So it removes it changes the 14 volt to the 5 volt that your receiver would require. It- Um, so we will bring power from our power control board up into this connector here, and we've got it's fused, and then it goes through the buck converter, which drops that power down to the appropriate power for the different output. Our nano, and this is a soundboard here on the left. So we'll add our sounds and stuff in here. Our um, Arduino Nano will control some of the soundboard as well. The information that will be sent to our motor controller will come here. The little board up here, this is um, oh, the motion gyro, right? This is what's going to help it self-stabilize. This is already pinned in, so we don't have to do any of the wiring of these components here, which is going to save a lot. And you'll see that as we move through. This is a slightly modified version of the board. So if you are going to use the tiny iBus receiver, in this case, it's the FS-RX2A 10 channel receiver, uses iBus. So you would get rid of like this whole one side of the board and the Arduino Nano um, in this process. And it would just plug in right here, your servos plug in and you're done. But if we scroll all the way down here, you see this attachment, the DO all-in-one 1.4 V1.3. This is the wiring schematic that we need to look at. We also have the Nano sketch, so this would go on the Arduino Nano. Um, so that sketch actually goes on this board. There's another sketch that goes on the actual Atmega board that holds this, and we'll pull that from the standard Michael Badley file. But anyhow, that other, if we open up that PDF document, it kind of talks about the wiring and the differences between the two types of boards. And the recommended wiring need to use this um, the smaller remote, but we're not doing that. We are basically using this. So we'll have our servos will connect directly into our receiver. We'll have a series of lines that come out of the receiver to the board on the right-hand side. Our speakers will connect to the board, and then we'll have a set of 5 wires that go from the left side of the board here. I think it was 5 wires that go from the left side of the board to our motor control. That's it. So this really cleans up the rat's nest of wiring within this build. So this will make things a lot easier as we go through and wire up the board. Like I said, if we were using the smaller one, it gets to be even less. Now I still did not order the switch. You'll have to bear with me over the last couple of days. Like I said, it's been a little traumatic at work the last couple of days, so I will get that switch on order. We'll have plenty of time to work on things between now and Tuesday. Tuesday, I think we will definitely be in a position where we can start programming the Arduinos, programming the receiver, and get things going. Okay, so as long as I have the switch by Tuesday, we'll be good. And welcome in, Timor. I do want to say that I'm not sure who all's on here yet, but all of the folks who had won things in last Saturday's stream, the vendor notifications have gone out. The I've gotten the addresses for the folks that I needed to send things to. Those are prepped and ready to go, and I'm going to drop them off at the mailbox tomorrow, and then I will send out tracking numbers. Hey, why not? Because welcome on in, and thank you for the resubscribe. Appreciate that. So where we left off Tuesday. We had just finished wiring up our motor controller. So we've got from our power board, we've got the connection that comes from the, whoops, sorry about that. Let me switch the screens again. There we go. So we have the connection that goes from our PCB controller, power controller, into the center jack of our board. And then we've got each one of our motors coming over and connecting in. Now, what we need to do though is take this back off, which means I'm going to disconnect the 2 motor wires, and that will allow me to remove the 6 screws to take this top panel off, because we need to come back over to our tool or our head box piece here. I'm going to take that off for now. And we're going to cut our wires and create our connector at this end. create the connector, the joining connector on this length of wire, and then we need to run it through here so we can do the rest of our wiring. So that's where we're going to start today. And to do that, we actually need to go back in the manual because we skipped a few things. But we were at step 12 in section 4. We're going to come back here and go to section 3 of the head box and neck assembly. I'm going to desk scroll real fast down to the bottom. So we did get this piece there. It is, it did, the epoxy set nicely. So I may add another little dab of epoxy in here, though I don't know if it's really needed. We did get some good epoxy there. So this is really good. Now this does need to be spray painted white. That's the nice thing is it'll be easy enough to spray paint white. We will be doing some finishing on all of this. So this is going to come apart and get masked off and painted. And so here's where we're at and where we stopped the last time. So we're going to take these wires as they come out here and we're going to cut them pretty short. And I'm just going to set this on the box because the this head box piece goes one way or the other. So I just want to set it down like that. So I'll be able to get with the wires here. And trim the wires, but leave enough length where you're comfortable with stripping the wires and crimping on them. Okay. So we're going to need to cut these wires down and then we're going to be doing some crimping. And what we're probably going to do on these thicker wires because of the DuPont connectors, I'm probably going to strip them back a little bit more and then put some heat shrink on them just to make the wire itself thinner. Okay. Okay, you sent out the forms, Pezliz, but most people haven't confirmed. Okay. And I know Jason at LDO Motors had said he hadn't been able to get hold of TechJeeper, but we got that squared away this afternoon. So they're now in communication. And I got all the names for the KB3D gift cards to Chris. I sent them via Discord and an email, but I haven't heard back from anybody. So if anybody was on the list for the gift cards, if you have gotten, if you've gotten the information from Chris, please let me know. If not, I will ping him again and try and get that stuff squared away. Once again, we're going to be doing some wiring and we're going to have our snips. And this is just to cut the wires because I find that works better than the snips that come in your strippers, or at least some of the strippers. A pair of wire strippers. I use, so this is weird on DuPont. I tend to use this to set the crimp that goes over the wire and then finish up with this style, which is more of the DuPont style, for the part that goes around the insulation. It just works for me and I get a lot better crimp, a lot better reliability. I think they're really busy with the black box, Nick. So I've got my order number, but I don't have a shipment notification. So I'm sure that they're just busy getting everything packed up and ready to go. Now let me double check here. We are doing the female crimps. And so the difference is, and I always tend to get these screwed up between female and male. So the females, are like this. They're actually designed for a pin to go into them. Okay, female, something goes in. The males are like this. They're the ones that have that extended pin in it. And so what winds up happening is the pin, whoops, as I just dropped those, the pin goes into, I'll call the rectangular box of the other end. So these line up and the pin will go in. So that will make the connection on. So once again, male is the longer with the pointy pin, and the blunt edge will be your female. These are the ones we're going to use. Um, they're an eye crimp, but they're basically the engineering PO9s is what they're basically are. This is the IWIS 2820M off of Amazon. I think you can also get them off of KB3D. I use these for all of my JSTs, but once again, I will use these for the first crimp, right? I don't know if you're familiar, but you'll have um, one crimp that goes around the wire, and then you'll have this longer crimp at the end, and that goes around the jacket. Now on a DuPont, those two are offset, and they're made to curl around like this. Where on a JST, they're in line and they're made to crimp down like that on the wire. Okay. And so that's why I'll use this to do the one on the wire and then come back and use the regular ones to crimp on the insulation. I just get better. If I try and do it both with this, it never works out right. And I get a bad crimp that I wind up just throwing away. Um, okay, cool. Um, yeah, where we're at. We are going to cut these wires and then we'll start working on our crimps. And now, mind you, we've got some length up here. So if we need to play with some length, pull some more through one way or the other, we can. It just may take some disassembly to be able to do that easier. Um, but it is something that is doable. Okay. So, but I'm going to kind of get these things crimped or cut, and then we'll work on getting them crimped. And I'm probably going to err on the side of a little bit of extra just because I know me. Um, yeah, we'll just leave it like that. I know me. And once again, on my thicker silicone gauge wire here, I am going to strip back more and then do a little bit of heat shrink on there because that'll give me a thinner insulation portion and I know it'll work better. So, yeah, I was going to say iWis was rebranded as iCrimp. And then, yeah, I understand the engineering PO9 are great. I still may wind up getting a different pair down the road. Um, if I can. And once again, it'd probably been better to put the heat shrink on these before I went and pulled the sheathing off, but so be it. Makes it. And I can probably bring the other camera in here and we can get a little bit closer to see what I'm doing. Yeah, there we go. A little bit closer so you can see me and my floor crimping skill or whatever we're going to call it. Um, I always feel like I get my heat shrink tubing like mixed up or intermixed, or at least it just looks like it is. Once again, the goal here is just to make it a thinner insulated area because I know that'll work a little bit easier with the crimp. So yeah, at some point, if I continue to do these builds, especially if I decide to get into an even bigger droid build, like doing a full size droid, I probably will go and get, start getting some, I'll say, better crimp tools than the ones I have. Um, just because the better the tools, the better the results. Also, well, the better the chance for better results. Using the wrong tool for the wrong job is just leading down a path, a slippery slope of mediocre result. So spend the money, get the right tool for the right job when you can, and if buy the best tool or the best quality tool that you can. Right? If you go out and you get a cheap tool, you know you're still going to have quality issues. Well, I said I should have put the heat shrink on before that one. Well, I stripped them. Like I said, it doesn't take much there. I'm just trying to get um, the thickness of the insulation to be a little bit less because I know that these DuPont connectors can be a pain in the butt. And we have 5 wires that we're going to be cutting here, so we're going to put those into a 2x3 DuPont connector. So, and the plan here will be to put the 3 um, servo wires on one side and then the plus and minus on a different side. So like in this orientation. The bottom three will be the servo, and then the plus and minus will be in the top left and top right. And then when we do the other side, we're going to make it so that they line up and will join up. So yeah, most of the stuff has been, most of my crimping, in fact, I'm going to sit down while I do this. Most of my crimping has been with JSTs because of the printers, and then some microfit threes because that's just the nature. Those are the things that we tend to use most. Is well, JST, microfit three, and then DuPont. Yeah, and getting the insulation position just right, and that's why I've cut it back because I have found that if you try and shove that thicker wire in these DuPont connectors, you'll you'll bulge the bottom of the plastic and you have a hard time getting them in and out, and then you wind up bending the wire trying to get it in, and it can either be a bad crimp or you wind up breaking and stressing the wire. So once again, what I tend to do is around the wire, I will crimp using my call them um, your engineer PA09s or what have you. And then I will come back with the DuPont connector to do the part around the insulation. Can always be a few thicker gauge wires. And there was a part of me wondering, like, would microfit and a locking connector be better in this particular specification? But this is what they spec'd out. They also spec'd out 18 gauge wire. And the more I look at it, I'm actually wondering if 20 gauge would have been enough for these servos rather than going with the 8 gauge. Oxford. Just the time when it's worth keeping it on the strip when you're doing this stuff, because it gives you a little bit more to hold on to, trying to get everything. And then once you get the wire portion done, then once again, I'll come back in with my DuPont connectors. I was trying to figure out which way it goes. We'll crimp the other portion of the wires. Bend these over just a little bit to get them to be able to go in. That's what we're trying to end up with. Focus. This. Please focus. This one's not going to focus for me. But yeah, you're trying to get the bottom portion of the crimp that goes around your insulation. Like I said, it should wrap around each other and kind of like your fingers when you interleave them together. Where on a JST, they kind of roll into each other. On the DuPont, they go next to each other. Okay. And then do a little tug test to make sure that nothing comes off. Um, that is really wish focal length. Try with the other camera here afterward. I can live with that one. Now we'll go ahead and work on this other one next. And once again, it might be easier to just clip that strip off, right? Because this gives you more area to try and hold once you get your piece put in. So what I mean by that is we're going to kind of lay this piece in there, line it up with where we get our wires going into the part that we need to crimp the wires. We're going to kind of push it down in there. Now I've got this wire strapping that I can still hold on to, and my fingers are out of the way when I go to crimp this top portion here. So pull it off. Back in here makes everything's nice, tightened down. Have a different one. And don't be afraid of, you know, pulling a crimp off or cutting the wire and re-crimping it. You want to make sure that you get a good crimp, so that you don't have electrical issues later on. And so your connectors work well over time. And this is a pretty tight fit for 18 gauge wire. Okay, one. Now pull strip. Okay. Then our next ones will be a little bit easier and a little more standard, other than it's step wire, so trying to get a little bit off the end. I don't know if you can see that it keeps kind of pulling out further and further. This is why I hate step coated wire sometimes when you're trying to do um, your stripping, because it just trying to get hold of it to get this stuff in the butt. Do these one at a time, and on these, on the thinner wires, it's easier. I just go ahead and get it in my crimp, and I can take that wire, stick it in there to the correct spot, crimp it down. Then I can come back with my other piece, other one, get these lines. Okay. But we'll get that one. We'll do these other two, and then we'll be able to um, get these into the connector. And then after we get it in the connector, we'll be able to grab the other wires and work on the opposite. And like before, we'll need to remember what our colors meant, which color went where, so that we can then do the wiring appropriately when we get to the box. We're going to match colors between this connector and the other wires that'll go into the box. Um, but it'll be matching them up when we get to the controller in a minute. That'll be critical. And some people go through and they'll get all their wires pre-stripped and then go in and do it. I do it sometimes. I'll do it one by one sometimes. Just kind of depends on how I'm feeling that day, I guess. Two and one more. Yeah, the real Molex crimper is definitely worthwhile. But like I said, that's if you're going to be doing a lot of Molex stuff. Um, you can use these for Molex and just about everything else. I keep looking at getting the standard iWis um, crimper for Molex and microfits. Um, but yeah, it just comes down to, do I want to get it right now, or do I have something else on my list of things more pressing? Um, okay, so on our wires, we got them separated, we've got them all crimped on. Now the next up is we're going to do the pinouts. And yeah, so pin one is technically where the little arrow is on your connector. There's a little arrow up here. It'd be on the top left. Get the So it's this top left pin would be pin 0. Like I said, it doesn't really matter. It's just a matter of what orientation you want to put them in. I'm going to look at this and say, I kind of like want to work my way up. So yellow is the head box. So I'm going to put that one on the opposite side. We're going to go yellow. So you push it all the way in, and that your clip goes down and that gets captured. And the next one would be the neck, which is green. That'll go in the middle. Basically, I'm going head box, neck, and then head plate. Okay, so all three of those snapped in. Now on the opposite side, um, that he did ground in that first pin, so that's kind of what I'll do is I'll just put my black wire or my ground in that pin, get it lined up. You can see this is where I'm going to have issues with these. These are not going in, kind of too thick. Yeah, these are still too thick using that 18 gauge wire. And unfortunately, if I kind of try and crimp it too much, I could actually like sever the wire. So I do have to be careful trying to crimp this down a little bit tighter. But yeah, we're not even getting it close. Like I need another 4 millimeters to get in there. Ooh, yeah, 350 for crimpers? That would be crazy. Hey, Kenneth 3D Prints, how's it going? Or Voron got, yeah. I wonder. Hmm, just trying to think aloud. Well, I say I'm trying to think aloud. No, I'm not. I'm trying to think. Um, so the wires go through this hole. That's why we got to be careful of the amount of space that we take up with any connectors. So using the Molex, or not Molex, but the DuPont 2x3, and that's pretty darn close. Thought would be, and I do the DuPont for the smaller wires and possibly get in there with a Molex microfit for the bigger wires. Give me 1 second to grab my Molex microfits because I know the Molex will work better with the thicker wires because it's kind of designed for it. But the Molex microfits also have the latching feature, which may cause us problems, especially if I can't find a uh, two count. This would be a uh, three. Yeah, and that's definitely not fitting in the hole. Hmm. Think through this one for a second. Um, let's say for a second, well, I could probably modify the connector just by cutting away some, but if I do that, I'm going to have to cut a lot. I do. Hey, Ferret Fawcett, how's it going? I got your email with your address, Ferret. I am uh, brain farting here. I've got the package ready to go to the mail, and I'm going to take it down to the mailbox tomorrow because after the week that I've had, I took tomorrow off. So yeah, I'm just at a point where I needed the time off. Yeah, so I have made these as thin as I possibly can, and it's literally the 18 gauge wire not getting that's not going to go in there with any type of without a lot of force and potentially damaging. Like I'm starting to bend the plastic on that, and unfortunately, that means based on where how far up this connector goes, that I would almost have to remove all of the lower portion of the connector, get the 18 gauge with a DuPont on it in there. And I don't have a different size of DuPont. So I'm serious. There's a part of me that's just wondering like why, I still wonder why we used 18 gauge instead of 20 gauge to run this, because this should all be um like what 3.3 or 5 volt going to the servos. We have the same thing on the other side when we try and do these as well. We're going to still run into the problem with 20 gauge wire. Hey, Creatix Brit, how is it going? How is it going? So we're having some fun here. We're trying to work on the wiring, and what we're finding is on the DuPont here, which is what they're telling us to use, we had used 18 gauge wire because that's what they told us to use. And I'm feeling like that 18 gauge wire is just too big, that 20 gauge probably would have been the better spin of wire. I'm gonna come up here and double check that it can call for 20 gauge, or I'm sorry, 18 gauge. These 5 total wires, 18 gauge red, 18 gauge black, and 26 gauge for the. So he says he did use 18 gauge, but 18 gauge that I am using is, it feels like too much. I understand it for the motors because of the current draw of the motors, they're going straight to the battery pack, but the servos are coming off of the head. Um, so I think what I may do is try and I'm going to take it apart and replace the 18 gauge that I used here with 20 gauge, which should be thinner, um, and allow me to actually, I don't know, put some DuPont connectors on and get them into a connector. So we'll have to try that. Yeah, because just the difference in the thickness in the gauge there tells me that I would probably have a better chance with the 20 gauge getting in there. Used about 27 inches. So let me measure and cut another length of wire, and then we'll have to do some reconstructive surgery here. I'm going to cut this just a little bit longer than I need for the 27 inches because I'm going to have to figure out a way of pulling it back up through all of this nicely. Yeah, Britt, we're having fun. We are doing the droid build. We're figuring out where we need to make some adjustments and making some adjustments. Um, I did get, I did find the right schematic that covers the boards that I purchased for this build. So that's going to make the wiring easier without having to do as many wires and crimps and solders and stuff like that. But in this case, it's just a matter of fact of he said he used 18 gauge. That's what I tried to use. And I don't know if it's that he was using 18 gauge FEP wire or what, but I cut the um, the silicone sleeving back and actually um, used heat shrink tubing to try and minimize it as much as possible. And these DuPonts are still way too big. So what we're going to do is we're going to pull all of those out so that we'll be able to do some surgery in here and basically swap some wires out, which means we'll have to do some resoldering up at the top. But what I don't want to do is like, oh well, I'm 18 gauge all the way down here and then do a little 20 gauge jumper. That's not good either. So we'll kind of do a little bit of disassembly here. That screw out. Oops. Get my 3 wires out of this connector. And Britt, thank you for reaching out. I appreciate I appreciated that. Going through and using my tweezers to lift up the tab a little bit so that I can then pull the connector out of the housing. Then I'll be able to pull this end piece off. And how much of this do we get to disassemble to get these power wires? Okay, and this is where it's going to get fun. Let me move some things out of the way and we'll go over to the big camera because we're pretty much going to have to disassemble this head to get to where we need to go. So way that, this here, basically close things up so I don't knock them over and make a big mess or any more of a mess than I probably will already do. Already knock something off this side. Okay. Something apparatus. Yep. Yes, it does. Yes, it does. So we're going to swap cameras back. There we go. Yay, camera. Coffee. Now we're basically going to have to go backwards. So we're going to have to take our head plate off. We're just going to loosen this bolt up here, rotate it back, the not bolt, but nut. And then that will allow us to take this off, kind of move it to the side and push it off. So there's the head plate off. Now we've got all of our wires here, and I need to take this neck assembly off. But to take this off, I need to take the servo out so I can get to the screw that mounts this to the next servo. And I'm just going to have to, like I said, just keep peeling this part because this neck, remember, is screwed through this bottom plate. And this wire goes up through the box. So we've got to basically tear our neck down. And the only way really to do that is to disassemble it. So we'll go through a little bit at a time, disassemble it. Hopefully we can just keep working around the wires. Now that we've got our wires soldered up there. That one. This servo should be able to pop out gently, possibly gently, not gently. That servo's pulled out, but I can't pull it all the way through because of all the wires. But that gives me the ability to get to the other screw, which will let me dismount it from the next servo. So this whole center black piece can come out. And see where I'm at here. Wonder this is connected to that servo. I have to keep taking like servos out to be able to get to the next screw to take the next piece apart. How fun. This might be why it might be a good idea to use connectors up at this end. So I may wind up going ahead and swapping these out with connectors at the top end as well. Because it would make any other, meaning rather than doing the joints like this, do DuPont connectors up at this end as well and make it fully modular and easy to take apart. Just going to scoot that to the side and see if I can get to that screw. And if I can get to that screw, this is the one that mounts the whole neck assembly through the box. Whole neck assembly can then come off. Now I'm at least seeing where my wires are at, so I should be able to pull my wires through. Should be able to pull my wires through. Very, very tight joint. Take this joint apart as well. All right. That was more of a pain than I wanted it to be. Now we're just going to fish this back through here. Start assembling things a little bit at a time. I left myself some extra length on both sides so that it'll make things assembly wise, hopefully a little bit easier to get things back in here. So we got that. Gonna pop on there. Of course, this piece was supposed to be um, glued on there, and I just popped it off trying to get that off. So I'll have to figure that out. Need to Yeah, so in this case, we would have had the head bar installed and then pulled the wires through because once the head bar is in there, this channel is accessible to get the wires in and out. So fun. Hopefully I don't have to recrimp all of these. Oh yeah, that esoterical guide is amazing for getting your CAN bus set up correctly. Um, that is a definite. That back in, you use the long screw, goes all the way through. and hopefully these all three through the hole. That is a yes. That now we need to pull this one through there. Over to this has been fun. Crossbar in there. And this will come back over the top. Through there. Line up there. Put in this screw. Which sorry folks, I know I'm not talking much, but it's just trying to make sure I get things lined up and wired back into the same positions again. Feeding through in the same way. this servo back in. I think our chopper and cheap droids would be a little bit easier than this Creatix Brit. And I say that because I think it'll be um, more space to work in what I'm dealing with right. Yeah, I was talking about the build for cheap and or chopper, even with the mini, should be a little bit easier than this, just because it'll be a little bit more space than what I'm dealing with right here. Piece of this. So me having this difficulty right here, do not think that you'll have the same type of difficulty when you're doing yours. Is where I'm going with. Servo. This one was a pain in the butt to get in the first time. See if we can get in there this time. It was a pain in the butt to get out. Here we go. Yeah, I've got. I think I have all the parts for the mini chopper. Um, but I think before I get started on that one, that I'm gonna work on prep and paint for some of it before I start actually assembling on that one. Okay, final one, and we'll be back to where, well, sort of almost back to where we were. We'll have, I'll put the head plate on, but before I do that, I think I'm going to once again figure out my length of this wire. Oh, there on the lower portion. These through here, through the bottom hole on the bottom. Hey, there's all. And the nut fell out of place. Literally missing it. One fell out of there, but there's also the one missing out here. And All those, we're going to this line up through. Oh, I knocked it up. Yeah. Okay, got it that time. Okay, so we're kind of back to where we were. Um, we'll need to work our connections at the top for our black and red. Basically, we'll just cut these off and we'll resolder this at the top. And then we can do a connector for these three servos, or we can leave them that way. It doesn't matter. We're good. We're good. We're back to ground zero. Now we're going to snip this off and we will put our DuPont connectors on our 20 gauge wire. And then that will give us the ability to finish our wiring. And once again, it's just the fact that this 18 gauge is just too thick to do this wiring and be able to get into the things. Sorry about that. So, not a topic for the current project, not a problem. You're running CAN bus on your 2.4. What's everybody's take on top hat space? Does it hurt chamber temp? Um, I have seen people that have done top hats. Um, just know that your heat rises. Okay. So your heat rises and your print is already at the bottom side of your build volume. So increasing it just means it's going to take a little bit longer for that heat to fully permeate all the way down. But if you have some type of circulation fans like Nevermore or bed fans, the side bed fans, that may help get the circulation through there and enable better circulation to pull that heat back down to the lower part of your build volume. So here's the thing I want to do before I go and do these terminate these sides. I'm going to grab my other 18 gauge here. We're going to do a simple experiment. We're going to put DuPonts on this and see if we can get in there. And if not, then that'll tell us that we may have to do our same uh, shrink wrap trick that we did over here. Go ahead and so I'm going to terminate this end before I terminate this end that's cut to a specific length. So that way, if I have to do any machinations, we're not hurting ourselves. This is the 20 gauge. And this side, I need to test the male pins. So I'm just gonna put a male pin on here and see if I can get it in there. And if not, then I'll come back and I'll figure that out. But one side of this is going to go into the servo connector. So we're probably going to just uh, solder these because one of these is going to go all the way into the um, receiver. And then the other side, well, channel one is a full run from the main servo, and that's going to go into channel one, and it'll have power and signal. And then let me rephrase that. It's channel three. Then four, five, and six are these three wires that are going on up to the head. So they're all pulling power from that one servo. That makes sense. Got around the wire. Jacket. Okay. Now I just want to see if this will fit in to our connector. And if it doesn't, then we'll have to pull back the insulation wires so we can get it initially on. Yeah, even with our 20 gauge, we have that issue with a wire where it's going to bulge the connector. So what we can do is the same thing we did before. We'll trim off some and then we will do a heat shrink on it, and that should get it down to where it'll be a nicer fit um, in our connector. Once again, we're just trying to make it center overall so it can get into the DuPont connector housing easier. Hey, Nick, how's it going? Bigger is harder to build and maintain. Um, we got here. You have a Nevermore, but my bed is also insulated. I have quite a mixed review of bed insulation with Nevermore. Would it benefit me to remove it? I do not know. I have never used insulation on my Nevermore beds or beds with Nevermore on it. In fact, I haven't insulated any of my beds um, at all. So um, I would say though that um, your Nevermore is still going to pull heat and it's still going to blow hot air through your filter material and then back up into the printer. So that's going to happen regardless. Um, I just don't know if it's going to impact good or bad on your um, on the actual heating ability of your bed if you've got insulation in. Okay, and you'll see what I was trying to do by using the heat shrink. You can see the difference in the size. So you've got the bare wire, the heat shrink, and then the actual silicone. So by doing this, we should be able to get our crimps done and get them in the housing. And so on our joint or on the other connector, we're going to use the male pins. So I'm going to go ahead and put the male pins on these and then make sure that I can get them in the connector. Hoping we should be good now. Mm. 2 by 3. little bit. Feel like it's almost there, but it's not like 100%. That one got in there. This one. Okay, we got power and ground in there, so that tells me we've got a winning solution now. We need to do the same thing over on these short wires coming out of the neck here. So we're going to need to trim these off, do a little heat shrink on them, which ought to be fun. Then we will go along with our wiring deploy today. Okay. Once again, I probably should have put heat shrink tubing around it before I take all the fun out of it, wouldn't it? So let's see. What we got going. Um, yeah, there's some good deals out there for AliExpress, and The kits are getting better with, we did the Formbot Micron kit, and that was pretty good. Pretty decent. I mean, they're not going to be like the super high quality, high wind rails for the um, for your linear axis. But then again, even on the LDO kit, you get an actual high wind for the X axis only. Everything else is LDO brand. You get a high wind if you use the Chaotic Lab CNC tap, you'll get a high wind. But for the most part, the LDO rails are quality. KB3D rails quality. Berserker rails from West 3D are quality. Once again, we're doing um, 3D printing. Having the highest quality high wind rails or something is really not important for the printing that we're doing. Um, Having those would be more important, like if you're doing straight up CNC machining and stuff. That's not what we do here on our printers. So save the cost where you can and get good print quality. Some of it can be um, squared away with the time that you spend tuning your printer, right? That's where a lot of people be like, oh, well, I used all these premium components. Why am I still having issues? Well, you built the printer and you tuned the printer. That's going to be the vast majority of the issues that you're experiencing is in those two areas. Not to say that you built wrong. It's just that's where you, the builder, have the greatest impact. You can have the best um, parts out there and still have a bad build because of you yourself, right? And your build quality. Same thing, I was building an airplane, and the quality of that airplane, the end result of that airplane is how much time, energy, and love I put into that build. If you rush through it, you're probably going to have some issues here. Yeah, and when you clean and grease, once again, you can soak them in IPA and then dry them out real good and take your time. Possibly even put brand new quality bearings in them and then grease them. But it all depends on the amount of time you want to put into each area and what your return is on the time and energy that you put in, right? I said this before. I had a professor one year that said, "Hey, um, not everybody needs, there's only one person in each class that gets valedictorian, right? So if your goal is not to be valedictorian, don't kill yourself. Focus on the core classes to your discipline. If you're going to be a math major, do you need to have an A in chemistry? It's a requirement, but do you need an A or in chemistry to be a math major? I will say no. So spend your time and energy where it matters most for the build that you want to do, and then work from there. So go ahead, and this is going to be a little bit more of a pain in the butt just from a working with any stubs of wire now. That one and one more. Oh, looks like we're having an ad that'll start in just a minute. Fans it came with are also well, and yeah, fans can be good, fans can be bad, and loud fans aren't necessarily bad. Once again, are you going for quiet or are you going for good cooling? Last thing you want to do is add 5 times the number of fans to get good cooling because you want to go with silent fans, and those quiet fans are going to cost you some too. Yeah, so the DFH kit that we're doing, I can't remember what I paid for it, but it was not an expensive kit, and it does come with a bunch of upgrades to it. That's the thing is, you know, be a consumer, know what your purchasing power is, and when is more advantageous to use said purchasing, right? Um, so there are sales and deals to be had at certain times of the year. Right now, we've got Chinese New Year going on, so a lot of your vendors may have had sales, so you could leverage those sales. Just be aware that it's Chinese New Year, so you may have gotten a good deal, but know that it's going to take a couple of weeks before they even get around to processing those good deals, right? So just be cognizant and aware of that. Could be good. Okay, so need to do a little matching. Whack. Goes in just fine. The other we got that. Now on our other side, what did we do? We did that, which was green. Facing whoops, we wanted the head box, then the neck. Yellow, green. Quite honestly, it doesn't matter. Box, yellow, and green. Green. Decent. Sorry, folks. No, I'm not probably good on. Plastic. Blue. There's our connector. Now, when we do the other side, we need to make sure that everything lines up when we do the orientation, do things that we are red to red, black to black will be the same on this side. So now we can set this piece aside for the moment. We are going to have to, like I said, redo the soldering up here for these sets. But for now, we're going to come over and finish doing our other wires that will join up with this. Going to take 3 ends one side here and strip them back and put the male DuPont connector. That's true. Just because you go to college doesn't mean you come out smart. I worked with a guy that had 2 master's degrees, and the guy could not write a complete and coherent sentence in an email to save his life. Drove me insane. course, he was a uh, engineer, like a network or systems engineer that everybody thought walked on water. The guy couldn't actually put together a proposal or anything because he couldn't write. And there is no need whatsoever for these to remain intertwined like they are, other than just wire and cable arrangement. So if you have separate strands of wire, don't worry about it. I'm just trying to keep mine kind of wrapped a little bit because it'll be easier to route a little bit later on. These three put in with the Yeah, is anybody else working on anything exciting? Any new machine builds going on? Any new um, projects anybody started? Almost done with your Trident build. All right, kids. That's what I'm talking about. You're doing your first MMU 14-hour print. Red Red Dad Steve Garfield. Nice, Panthers. Now, when you say MMU, are you talking about your AMS print, or are you talking about MMU um, on your Prusa? I know we talked about it before, but this is going to be the year of multicolor here on the channel because we're going to be going not just with um, an enraged rabbit carrot feeder that we're going to put on the Trident 350 build, but we're going to have a enraged rabbit carrot feeder on the 350 build. We're going to get the MMU3 for our Mark IV, and we're going to do a rebuild of the trad rack and get that added to the K3. And then, of course, we've got the piece de resistance, which is our black box build that we'll be doing. So, and like I said, I'm pretty sure Chris and Chris are just jam packed on trying to get stuff done for black box to get those out. First batch orders will be going out. I am in that first batch grouping. So, and I believe Steve Builds is as well, and I'm not sure whom else. is in that first bill or first set of printers going out. But as soon as we get it, I've got all the prints done already to get started. Well, all the prints except for the enclosure and the water cooling, which, by the time we get building, I will get those printed up. It's just a matter of there's a lot of printed parts. So just trying to get everything printed and then stored is just kind of it's busy. These out now, visuals. And once again, we're going to get our power and black done. Flip this over. Then I'm going to figure it out. So blue, green, yellow. Blue on the closest to me. Then green. Then our green. Yellow. Okay, and that's going to make up our wires. And then I'm going to take the blue, green, and yellow and just go ahead and give them their twist again. Not twisting a lot. I just want to try and, like I say, keep them together. It'll make the wire management a little bit easier. So I'm going to scroll down to the bottom here. So we now have this end terminated. And that's it for this section. We'll jump back up here and go to the next section, which is the top frame and electronics. Now this is where we start with crimping the main bar wires. And so this is what we just did. This was the leftover wiring that we had here that we just went ahead and crimped up and made sure that it is going to match up wire for wire with our other set. So do this. Let me get some of this stuff out of the way. So we've got our end piece here. And we're going to take this, and if I go to plug this in the right direction, we'll have yellow, green, then blue, yellow, green, then blue. And on the other side, we'll have black and red. Everything's lining up. Got everything matching wire color to wire color. Um, Black box is a 5 tool head tool changer. In fact, let's so black box is a 5 head tool changer. Let's go full display real fast. And we'll play this real fast because, like I said, this is what's coming to us. Yeah. So the nice thing is this is one extruder that stays on the Z or the X axis. Then your tool heads just have the final gear. So your extruder motor is on the X axis. It uses water cooling. This cools the active tool head as well as all of your tools that are sitting there, not, sitting idle. So that is the black box kind of dealio. I want to say it is, what is it? Black box XYZ is the, oh, guess I'll be coming over to black box packages. Um, there is the configurator. There you go. Blackbox3D.xy. There we go. Thanks, Nick. And then yeah, and then there's the GitHub. So the nice thing here with the I think this is the Dazuki wiki, is it talks about what Blackbox is. There are kits. Um, you can go in and configure things how you want in the Blackbox configurator on KB3D's website, and you can build as you go, right? As you go. So it's just like any other printer. You can build it with one tool head and get a working, functioning printer, and then spend for the extra tool heads as you need to or as you can afford to, and build into a bigger or a multi-tool head changer. But in each section of the manual, you'll have um, you'll have the CAD of what it is you'll be working on. You'll have a PDF document that is that section of the manual, and then you'll have a zip for the STL. Right. So that's what I've been doing is I've been printing one section at a time and grouping all my printed parts together. So I can just bring one bag of printed parts over and say, okay, here's the printed parts for this section, and we can do it one section at a time. So the deal that I had with KB3D is he's providing the main printer, and I'm supplying all my tool heads. So I've got 4 tool heads currently spec'd out, and so that's what I'm building too. Is I'm going to have a 4 tool head. 3 of those are Revo with high flow heaters, and as soon as I can get my hands on them, because I'm not a big influencer, I will be getting the high flow obsidian nozzles. Right now, I've got 3 Revos with high flow heaters and zero.6 obsidian nozzles, and then a 4th tool head with a titanium heat break, a nickel plated copper hot block, and a V6 style Slice Engineering Gamma 0.6 nozzles. So all of my nozzles are going to be 0.6, and they're all supporting abrasive materials. Correct. It is a full printer build. It does use a 300 size Voron build plate, right? But that's just because it's easy to get. They're everywhere. Everybody has them. And it's spec to use the Mandala Roseworks build plates. And you can get a standard build plate and then use the sheet magnet with the build surface, or you can get the Mandala Roseworks magnet build plate. It's up to you. Um, yeah, it just they use components that are readily available in some aspects, and then other aspects like the water cooled heat blocks. Those are CNC milled specific to the printer. right? But your motors, they're not some crazy one-off spec motors specific to this printer. Okay, so the first couple of pieces in this section is building the main bar wires, which we have now done. We're validating that they they plug in and that all the wires do line up, which they do. And now we need to route that through that main gear. So this is where we need to, let me clean it up a little bit here by putting up my these together, get those scooted off to the side, get all of those scooted off to the side. We'll bring this back up. This actually goes in here. Try and get this sorted. This back on here just to hold that nut in place. Oops, sorry. Okay, so we're back here. So for now, I'm going to leave the head plate off, and I'm not going to redo the soldering just yet. I will get to that though. I do have my extra wires up here to do the said soldering with. I'm just going to wait until I need to potentially do more soldering or anything else like this. And I think actually I will cut this off just to get um, the excess wires flipping around and flopping around out. The other side off as well. Okay, there's that. There's that. We need to bring this back up. And what we're going to do on this piece is we need to get back underneath this plate. So what I'm going to do is I'm going to undo the motor wires, and then we'll be able to take this whole top plate off because everything else is connected on this plate. Undo those. Do these. Right? And then we will undo the 6 screws to take this top plate off. Yeah, now if you already have a 2.4, you could potentially do a tap changer. I know there's some changes going on with tap changer right now. That's why Zombie has stopped his build for the time being. Just because he's, in his words, for once, he's letting somebody else be the beta tester. So, which, trust me, I get. Um, and he's got 2 tool heads and it's working fine, but before he goes and populates the rest, he's gonna wait for any other changes to be made. Okay, this should come off if I completely undo the screw. There we go. And our motor wires will come through these holes here. Oh, like what am I stuck on? That servo right there. Okay, so here's our top plate with um, our board. That board is not secured down in any way, shape, or form. It's just kind of free floating in there in a friction fit right now. And I don't really see a need to like drill a hole and screw it down anywhere. So our wires, as we can see, I'm trying to figure out how best to move this. Maybe we will flip back to other. So now that we got our pieces out here, we've got our larger hole here. Whoops. There we go. The larger hole in this gear here, and then the hole back here that's in our main axle. This is where we need to take our wires. We're going to push this into the axle and down through the axle. We can hope get the connector. Right? Maybe, maybe not. There we go. And we're just going to push these wires and the connector straight through. All right. So that's where we want it. We'll make the connection and then we'll basically push this back in when we go to do we go to actually mount that officially finally. So we're going to have this excess in our servos and our piece or the top hat is going to go on in this way. So what we need to do is fish these up through this gap here um, where our wires would be coming up through the motor, the gap for the motor, basically. So, or the motor. So in essence, we're coming up through this little cutout that's left here. If we weren't using this board, there would be a larger spot for all these wires to come up through. But because we're using this board, we're going to have to do a little bit of routing just to make things come up and go through easier. Doing some thinking on which way I want these wires. I think I want to route them all this direction because these are the servo wires and um my I want to route all my servo wires and stuff this side because my controller when it sits down my receiver is going to be on this side of the machine. And then our motor wires we need to bring up through these little square holes in this printed part. So it's this little square hole right here. Need to bring these motor wires up. And just make sure everything gets lined up and slides back on here. Nothing gets pinched as we slide it down. I'm just going to kind of bring this around and lay these down so they're out of the way for the time being. And that will allow me to bring my motor wires back in and mount them once we get our screws in. This is a little bit tighter fit, but if you can imagine, you know, Okay, so we have the motor wires, then we have the wires for the batteries and all that good stuff in here as well. The wiring will get very, very complicated and messy. So having the um, circuit boards that I purchased, it's really going to clean up the wiring a lot and make it a lot less cumbersome for the wiring. But things do get a little bit of tight, a little tight. Go ahead and put this back together. How to do it without losing build volume? Yeah, there's plenty of mods out there to make it taller and to add a taller top hat. I wouldn't want to rebuild it, so I would make a top hat that would mount right on top of it. Um, so I wouldn't have to worry about that. So on our wires here, once again, what I'm going to try and do is bring my wires up, pull them to the side, and wrap them around towards the front here, just to keep them out of the way for now. And then this is the power that's going to come from um, my two battery packs. Will plug into the board, and this is going to bring that 14 or 14.7 volts around into my motor driver, and then both of my motors will plug in on either side. That's why I want to kind of keep these wires down, and that will allow me to come in and plug in my motor wires and get these screwed down. Uh, on both of my motors, which are the black terminals here, the power's on the inside edge, ground's on the outside edge. We just need to know that when we put these back in there. These were a little finicky to get in there the first couple of times. Probably get easier once we get them in there and get them a bit. Um, so they're in there and seated all the way in and really tightened down. Then we'll just move our wiring around to make it a little bit easier. Our other one's going to come around here, same thing, power on the inner edge, the inner ground, that outermost terminal. Do a visual check and the standard pull test. And we'll have to route this around a little bit around the battery pack and stuff. But that battery pack is going to slide right down in here and then plug into the terminal on each side. Same thing. So we'll uh, keep going after that. So we've got our wires in there. And everything's nice and neat for the time being. Um, so we've got that part done. We got our motor controller installed on the last stream. We just got all of that back into place. The switch wiring we have not done yet, but once again, I need to order the switch. It'll be here for Tuesday, which is perfectly fine. But that switch is going to plug in right here in this slot. So it's going to plug in and it's going to be the two wires right back to this connector. So it's a short jumper. And once again, you can see the complexity of the circuit it's starting to do where you would basically be pulling the wire to both batteries. And this board just makes it so much better. It's it's not cheap, but it's not expensive either for the boards of what you get. And it's going to make the wiring so much easier. So here's a little bit of complicated stuff to do your switching. You're having to this is the one plug because it's going in series. You'll do the one plug. This will be the negative or the neutral lead over to the other one. Here's your neutral, positive, and you're just making this big wiring harness. All of this is just for your batteries, right? Meanwhile, it for us, it's uh, we're going to do two wires and jumper it in, and it's done. So I think we're going to probably start deviating very quickly. We don't need the SBEC because once again, this is our buck converter and our power. This is going to sit on top of here, on top of our Arduino, and we're going to bring power from here to here. These are all our servo connections. These are going to be going into our receiver, and then our receiver is just going to sit in this gap. And then there'll be wires coming from the receiver into this board, right? We're going to have two speakers. We're going to have wire that comes from this speaker connection to this terminal, and it's going to come down to the speaker, which is getting mounted right here. And same thing for the front. There will be another terminal, and it's going to come down to the front speaker over here. And then these 5 wires right here, which are um, the motor controller, will come over and attach to our motor control. So you'll see that this makes our wiring so much simpler, just having this. So we don't need the UBEC or SBEC or whatever BEC, battery elimination circuit. We don't need to install the header on the MPU because this is our MPU. Header is already there. It's through soldered onto the board, and these are traced back already to the connectors for the Arduino because this is a hat that sits on top of a Arduino at Mega 250 or 28 or yeah, 2560. Ooh, that sounds like they've got a tack sensor on their fans, and the fan may be going. Rodney, that's what that sounds like. So we need another printed part, and that will be, I'm going to go back and switch the, we're going to need this printed part. Once again, this would be designed so that this board could be mounted directly here, and then your pins would be going up. But we're going to be going just like this. So we've got our board. We're not going to attach the MPU to this because it's already on our daughter board. This would be servo wires. Um, bum, 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 bum. Yeah, at this point, I think what I'm going to do is I'm just going to switch over to our main diagram here. and we'll kind of start working through it. I was hoping actually what I really just need to do, there we go, is this part here. Like, let's install the Arduino base, get that in here, and then everything else I think falls into place a little bit easier. Hey, Shenanigans, how's it going? Did not see anything on the wiki. Okay, so yeah, we're making some progress. Um, you'll need the Arduino base, the Arduino top, which is this piece here. Just got to cut out. You'll need screws, the Arduino Mega. It was going to be useful. We're going to need some screws. What do we need? M3 by 16. M3 by 16 screws. Um, two M3 nuts, and I think the M3 nuts are going to be what kind? Place the Arduino top on top of the Arduino, up the cutout with the screw. Bottom, insert the base, and we'll use some nuts. I was wondering if the nuts actually sat down in here, but I think they just go all the way through. So this piece is going to sit right on top of our Arduino with those pins lined up. And that covers up the reset, but that's okay. Make sure that you're um, then this sits down in the box with everything lining up. Your screws come up from the bottom and go up and through. And I'm looking at these going, not going to leave much threads, but probably shouldn't have a lot of threads exposed. And it shows using some regular M3 nut, a couple of those in here. Okay, so that's what we're set up as right now. I am a little bit concerned because those kind of look like those nuts are embedded in the print, and mine are definitely not embedded in the print, which worries me about standoff heights and whether anything's going to um, hit when this gets installed. And yeah, it may hit these solder joints here with the one screw head, or not screw head, but bolt head. That's weird. And I don't think that that print is wrong because if so, it would have started pulling through if there was like a oh whatchamacallit, a countersunk in the or countersink in the plastic. Oh no, I'm gonna have to take a gander at this. I'm fearful that once again that these would short out on the printed part because my nuts do not countersink into that plastic are are raised up there. But looking at this picture, it looks like those are countersunk into the print, and that is not the way my print looks or acts. So that is worrisome. Yeah, that will hit on the one screw. We will have to figure that out. We may have to print a new piece. There are instructions. So if you go to printed-droid.com, and give me 1 second, and I'll put the link up there. Sorry, I'm looking at this piece real fast. See if there was, if I had like an ear or something that printed around there and it didn't. Sorry. So this is the link here for what I am currently building. This is the D0 droid or Dio from Star Wars. He was in the Millennium Falcon on the last set of the trilogies with Rey and Finn when they left. I can't remember the planet that they left from. Um, and wonder I might be able to get away with just one screw for now and not mount the other screw. That'll get me around the main issue. Um, but he is the little unicycle droid from the movies, and I personally think he's pretty cool. He's in he's a, so by just doing the one screw here, this is pretty good because it's two screw points and then there's a printed part right here, and all we're doing is just trying to secure that Arduino into the case so that it doesn't go flying around. But I'm worried about these solder joints touching if I do the one screw hole right here. The other side isn't going to align with anything, so I should be good there. Should be good there. I would feel better if there was actually like no chance of anything touching whatsoever. But yeah, it is not touching height wise. It is not touching the board. I've got light between two boards that screws that. I'm I'm happy with that. I'll be happy with that. Um, sorry about that. So, oh, thanks. Hey, Urban Monkey, how's it going? Put some Kapton tape on it. Yeah, I can put some Kapton tape over that point, but putting even with the screw head right there, even if I put Kapton tape, I'm worried. I'm really worried right there. This is good. There's clearance. I've got physical clearance here. I could put some Kapton tape, hot glue, whatever over that. That's no big deal. I've got Kapton tape. So, like, yeah, I've got Kapton tape. Now, where's it at? Here we go. We'll just add some Kapton tape to it. And we'll go ahead and mount our other board. Once again, this just lines up with the side pins of our Arduino Mega. And there we go. And that's pretty sturdy, even with just the one screw there, so I'm not too concerned. Um, Now, you'll notice that there are these 4 holes on this side, 2 holes on this side. Interesting mounting here, right? This is going to sit right on top here, and we're going to use zip ties to zip tie this down front and back. So, um, but I will say that when we do that and we zip tie it down, as you might be able to tell, it's going to cover our access to our battery holes. So I'm going to probably not zip tie it, or if I zip tie it, I'll just zip tie it loosely for the time being, just to keep it from moving around while we do some additional wiring and stuff. But I will, once I get everything close to finalized, then we'll zip tie it down for good. put some things up here. There we go. Okay. What else do we have? So it does talk about doing the servo leads for the the servos that we had coming up. So let's work with the wires coming from the main bar, which is this set of wires right here. Okay. Um, strip the ends of the three servo wires and put on a female crimp on each one, as shown in pic 2. So we'll go ahead and grab these three wires and do a female pin on them. I'm actually going to cut them to length or cut them all to the same length. No, we'll leave them the way they are. So female DuPont. Each one of these. Okay. I just realized that I pulled all my wires through because they're not sticking out. So let me fix that. We've got our three wires here. We will add female DuPont connectors to those. Oh, there we go. Okay. Same thing as before. We do the crimp around the wire with our standard crimpers, and we'll come back with the DuPont connector crimper to do the other part. Urban Monkey. Urban Monkey. So has everybody been Urban Monkey? There was hey, didn't you win something on the Saturday stream? Yes. Did you fill out your form for your Polymaker, Urban Monkey? One. You have not? Okay. I say I just want to make sure that everybody that got stuff has been contacted and has the information needed to either get their filament or get their KB3D gift card if they were getting a KB3D gift card. Now I got hold of Tech Cheaper, and he is talking with LDO Jason with LDO on the Smart Orbiter 3. And then stuff that I am mailing out, like I said, they are packaged up. They are sitting downstairs. And I don't believe Miss Dragon took them today, but I will take them tomorrow. I'm gonna get up and go have breakfast with Evil Diesel in the morning. Then I will take that stuff down to the post office afterwards. Yeah, I wasn't sure if it was coming from Zombie or if Pez was sending them out for everybody, but yeah, you were one of the Zombie spools, and I believe Pez said that her and Zombie had been working together during the stream to make sure they got everybody's name and stuff. So if Pez is still here, if she could verify and validate that for me. You did reach out? Okay, good. So I think Pez said, yeah, she was reaching out for both her and Zombie. Um, Tell you, it's the Zen Z show. She just lets him go first because she thinks, or let him think that he's in charge and important. Okay, so we've got um, male connectors on our 3 servo wires, and we're going to put these into a 3-pin housing. Go through a 3-pin housing, and the order does not matter as we can assign switch channels on the RC remote later. The order doesn't matter. We just need to know which channel each one's going into. Okay. You offered to do the hard work if you submitted the form. Oh, gotcha, Pez Liz. Gotcha. Well, thank you guys. Thank you, thank you, thank you. Okay, so we've got these 3 ready to go. We will once again, we need to add them to a connector. It's going to be a 3-pin, not a 2-pin. So standard 3-pin connector. It doesn't matter what order we're putting them in, but what I'm going to do is the power and ground that's coming out of the tool head wiring with these 3 servos. We're going to join the power ground from this one together. And this is going to go, I believe, into channel 1. And this is the servo that's down here that controls the head rotation front to back. Okay. So when I go to do these, I'm going to set them up so I can plug them in and go, uh, what is it? Head box, neck, and then head plate. So the head box is the yellow. So I'm going to put the yellow in the first connector hole. Make sure I hear the clip. The green is our next. That will go in next. And then the blue is the head box one. And that'll be the next. That's those 3 that we've got right there. Okay. Then next up, we're going to attach the power wires. our power wires here that go to the head servo, to the servo wires that are attached to the servo in the center of the frame, which is, once again, this servo wire that we have here. Carefully strip the power wires of the center servo, blah, blah, blah. And I'll tell you a secret, right? And here's the secret. We've got servo wires here. We can cut this, do some more soldering, and combine these in, right? That's one option. Or we can take these servo wires, cut them to length so that they match these, and we can create a different connector so that it all plugs in together, right? Meaning, um, I can do a 3 and a 2, or there's a way that we can do this, and I'll show you what I'm going to do. Is basically where I'm getting it. I'm going to make these. I'm going to cut this to size or length. Basically, I'm going to leave this connection the same. This goes into one channel. Then I'm going to basically create another one of these for one of these channel, and then the other two will just get plugged in. Oh no, let me think through that. Yeah, that still works because this is connected to all three in the head, right? So that's what we'll do. That's what we'll do. All about making my life a little bit easier and a little less complex here. So we're going to, yeah, I was going to say we need to strip this and put the little heat shrink on there still. The answer is yes. Strip a little bit long. We'll do our heat shrink on these. And I swear there is a method to my madness, or madness to my method, one of those two. There's madness somewhere. Oh, well, that'll do it. A little piece of filament lodged in a hot end fan, that'll do it. We just posted something like that. Was it Vez? Um, that just had an issue with his Mark IV that had a piece of filament or a wire that broke and had stuck into the fan. One. Hey, Aaron F. Geared, how's it going, my friend? Neat. Was that you with the broken wire on your Mark IV fan that caused some issues? What we were doing there is we were simply shrinking or doing some heat shrink on the wires. Whoops, I'm about to tip stuff over and make a mess. Um, and by doing the heat shrink, we flip camera over. By doing the heat shrink, it makes it just that much thinner. You can see the difference between um, the wire, then the heat shrink, and then the with the silicone insulation. So it just makes it a little bit thinner to make the DuPont connectors easier to get in the housing. What we're doing that for. And so we're going to do male connectors on these still. Crimp over the wire, and then we come back and we crimp the legs over the insulation. Right, go, done. Next one. Glad to hear things are going well, Aaron. Yeah, we're having fun. We had to tear the whole head apart to swap the wire gauge out. So the gentleman, when he did his build, said he used 18 gauge wire. And when I did 18 gauge wire, I could not get the crimped 18 gauge wire to go into the DuPont connector. So that was a showstopper for us, and we had to say roll the footage back some and swap over from 18 to 20 gauge wire, and that gave us the ability to get our DuPonted wires into the housings. Once again, it's 5 volt. I assume that 20 gauge would be fine. Hell, I would think that, I mean, standard servos. I've got servo leads running the full length of my dragster, which I think are longer than these, and that's not a problem. So, okay, now I've got to think. The brown is ground, red is power, and then signals the other side. So it's ground, power, and then signal. So ground on the outside, then power, like that. And then we'll need signals. So what I could do is take yellow, add it to this one. yellow pin, add it to this one. Then the other two, the green and the blue, we'll put into a 2-pin connector versus a 3-pin connector. That will let us do our other two wire receiver. Now I just did get a new remote and receiver for this because one, I needed a 10 channel, and my previous remote, which is also a Fly Sky, is a 6 channel. And my understanding is some of their 6 channels can be reconfigured to 10 channels by opening them up. But I also wanted the 10 channel receiver. And the nice thing is these remotes you can program a number of models into. So I'll be able to use this same remote for the Chopper Droid and others as well. So that's going to be nice, as it'll let us use this same remote for multiple models. We'll just have to get different receivers and set them up accordingly. I'm just going to put this back in the box for now because I don't need the whole thing out right now. Okay. Back. Well, no, we'll stay there. So, wiring wise. Got our little 10 channel remote. And two, servo wires coming from the center can now be attached to the RC receiver. The center servo with the power wires goes to channel 3. Okay, so our center one with the power wires, aka our center one, we're not going to break apart, is going to go into channel 3, and we need to make sure that we put it in the right direction. We don't have, oh wait, so it's negative, positive, signal. It's very, very small up there. So our signal, which is the uh, yellow orangish wire here, is going to be at the top, and we're going to go into channel 3. So that'll be the third socket. Okay, the negative power signal. Okay, our other one, this is going to be our next one, which will be the yellow wire here, which is the head box. We're going to do the same thing. We're going to plug that in right next to it. So it'll be negative power signal. Then these next two, we're just going to put into a 2-pin DuPont connector. Get one out. And next one up is the green for the head box, or I'm sorry, neck, and blue for the head plate. And these are going to go in the signal pins for the next two channels. So this is, whoops, sorry about that. this is how we're looking is channel 3, the uncut servo wire from the servo that's in um, the main frame. The next one has the power and the signal coming from the head unit, the head box unit. So this same power is going to feed all three channels 4, 5, and 6. And then 5 and 6, we just had the signal pins. What it was basically telling us to do is splice the power into this one, and then 4, 5, and 6 are just signal only. But it makes no sense. I don't want to cut this if I don't have to, because that's one less servo that I can reuse somewhere else if I ever take this. Okay, so this is our main servo wiring. Now the rest of these channels, channel 1, channel 2, and then 7 through 10, get connected to our board here. So you'll see negative, positive, channel 1, channel 2, 7, 8, 9, 10. We're going to be making a wiring harness that goes 7, 8, 9, 10 right down to signal, 1 and 2 right down to signal, and then the power would go, yeah, to the this very last spot. Yeah, that's how that goes together. That makes life so much simpler. This is going to, like I said, zip tie here. And this we're just going to basically bring up and stick on the side. Over on this side, whoops. So this board's going to zip tie right here, front to back, side to side. These wires, depending on how we want to run them, once we get our battery in here, maybe we can still stuff them around this edge here. And we'll just have our receiver shoved down on the side. This board comes across the top. The rest of our wires between here and the receiver. And then this side will be the wires that come out to our motor controller in the front. That's, I mean, we're real close to sort of being done almost. See what else it tells you to do. Get your battery packs and put them in, plug them in. Now, in order to do my battery packs, I have to do soldering. So I looked at this a little bit earlier. My battery packs, they do not come pre-soldered, right? We just have the bare wires there, but it comes with either the Dean's T connector or an XT60 connector. We've got the XT60 connectors on this board, so that's what we're going to use. So I just need to solder these XT60 connectors up to the wires for both the battery packs, and then what? We'll get the battery packs put in. Then we can do this. Let's go ahead while we just have it sitting here. We'll figure out our remaining wiring harness. Like I said, we're not going to need huge lengths here. We can use relatively thin wire. See, not saying what gauge wiring it. Quite honestly, if you've got jumper wire, this already got DuPont, you can use that. I'm just going to go ahead and grab some wire that I've got from other places and other projects and make that harness. In fact, that's fairly long. That should be long enough to go between here and here. So there would be 3 wires if I really wanted to do that. But I've got 7, 8, 9, and 10. So those 3 are together, and then um, channel 1 and channel 2 be those 2. Let's take a look at the wiring schematic here. Once again, these 4 servos just go into 2, 3, or excuse me, 3, 4, 5, and 6. And then it does show the rest of them going up here and making. So we'll just go ahead and start. Wire, where's my back over? Ribbon cable, and I don't want to. Yeah, let me go grab some wire links. Go come over here and grab the box of wire. And these don't have to be like color coded, different color or anything like that. If I want to sit here and really just use whatever wire, I'm good. Like I'm going to sit here and literally go back to the bigger screen. There we go. Boom. Here's another motor wire. Okay, so there's going to be 4 wires right there. 7, 8, 9, 10. That's going to be the 4 wires for 7, 8, 9, 10. I just need to figure out about what my length is going to be. Cut it, pin it, and we'll be good. Then we're going to need pins on the 4 ends. I'll just go ahead and do the 4 ends. We'll get it plugged in here. And we'll kind of see, okay, like where do we need to, um, like about how far do we need to go? Cut the wire. We'll screw in the 4 ends here. For these, I'm probably not going to put ferrules on them on the other end. The power and the speakers I may, but I'm not going to. Yeah, I guess I can. But we'll go ahead and get these 4 ends going. Maniac, how's it going? Welcome back. Welcome back. So did anybody see Chris's basements video? He just did a video where he basically used a, what was it, a Big Tree Tech Pad 5 and a CM4 module, and basically created a, we'll say, a remote control pendant for his clipper based printers. Thought that was kind of a cool little dealio. and like a little wireless remote for his printer farm. Oh, put that over there for the time being. I'll need some make some. I'm gonna sit down while I do this. Hey everybody. Bu- bu- you have that remote? I'm gonna go ahead and get our diffusers on here. And once we get our DuPonts on here, we'll cut it to length and we'll do the um, get these connected up. And this is going to be the 4 for channels 7, 8, 9, and 10. So Saturday, we're going to be switching back over to the Trident build. And the plan for Saturday will be to work on the electronics installation and the toolhead build. So the toolhead build is basically a stealth burner with a twist. And the twist is going to be when I build it, I'm going to go ahead and build slash configure it for the ERCFA 2, what do they call it? The philometrics. Basically the sensored up and cutting tool head. So it will allow us to, I'm going to do the full shebang on sensors. So we'll be able to have a filament runout detection before the extruder and between the extruder and the hot end itself. So we'll get it above and below the extruder gear, which my understanding will help dramatically with the ability for it to auto correct issues that you have with the loading and unloading sequences. And then I'm also going, we'll have the filament cutter as well. So we won't have to deal with trying to get tip forming to work right because we're just going to cut the filament like the bamboo style printers do. And then uh, once we get the printer up and functional, right? No panels, just up and functional, meaning we can push plastic and it's all moving in the right direction and pushing plastic. Then we will go ahead and go into the ERCFA V2 build, which will include the Enraged Rabbit carrot feeder and the the Enraged Rabbit cottontail. which is the filament buffer itself. So we'll go right into that build, and then once we have that built, then we'll go ahead and, you know, make sure that we can get everything configured, and then go ahead and close up the printer. Now, one thing is just under or trying to figure out like how I want to mount the enraged rabbit carrot feeder as well as the filament pen. So I think what I would like to do is do like I did on the zero G, which is drill a hole in the top panel so I can mount the ERCFA on the across the top of the printer and have the filament feed in right through the top center or maybe top slightly forward of the printer. And that way it'll be, I don't think, well, I was going to say, a little bit nicer, a little bit easier to work with. Okay, but here I need a 4-pin. This is the 4-pin connector, and it doesn't matter really in which order the colors are, other than whichever order I put them into the housing in is going to dictate the order that I screw them down onto the screw terminal. That makes sense. Okay, those 4 are in there. Connections are good. Everything stays. So that's good. Now we just need some length. So, hey, Westery One, how are you doing, sis? We're going to get a length, and we're going to cut this off. Okay, so this is going to be the 4 wires, so 7, 8, 9, and 10. So, like I said, it doesn't necessarily matter in which order. We just need to make sure that however they are screwed in is how they, what channel they go in when they get connected. So, um, we can strip and put ferrules on these, or we can just go bare wire it. I think we used ferrules already before on the motor wires, which are high power. These are low power signal wires. But let's keep with our good wiring standards. Okay, and I'm gonna use the. Well, we might be able to put ferrules on these. We might not be. They may not. They may not stay on here because I don't have the smallest ferrules I have are for 22 gauge. With this being 24 gauge, these may not grasp the wire. We may have no other choice but to go with um, you're going to solder them. Don't, but do only solder the tip to hold the strands together for ease of insertion, not the entire exposed length. Yes. Yeah, expose more wire, fold them back on themselves. That's another option. Testing and these seems to be working good. And once again, I am going to trim at least one section off of these just to make sure that they go in and they don't stick out where the too much metal's exposed and they could whoops lead to an issue. Those done, like I said, I'm going to clip the last end off. Hey Westry, I gotta ask this. Did you ever finish your round frisbee like object? Inquiring minds want to know. What I'm going to do is I'm going to take this and I'm just going to put it in here. So we're going into 7, 8, 9, 10. Right? We got that plugged. Whoops. Yeah, let's plug that into the signal side and not the ground side. That would be good. We're going to plug this into 7, 8, 9, 10. Okay. And that means that these wires are going to come up when we need to understand which ones are which. So blue is 7 and was it blue is 7, red is 8. So we'll go ahead and screw them down into the corresponding place. And then you just have to reinforce them. Okay. Well, yeah, my armor set is still sitting underneath my desk. At some point, I'm going to have to work on that myself. Really? It'll make me break the iFixit kit out. That and yeah, well, do it. Me, you. Okay, so once again, 7 and 8, so it goes blue then red. Red is 8 and blue is 7. The way around. Blue is 7, red is 8. And this is another one where the holes are holes are very, very small for the insert area, which means we have to add a little ugga dugga to our crimps on our barrels in order to get them into the holes. So once again, line up on the flats and apply the ugga duggas to the flats. Keep it square. You can go all the way flat, whichever. So all the way back in. In. Eight. And I'm going to make up two 2-pin connectors for channels 1 and 2, and then for plus and minus. So that'll be the last two, and the plus and minus, of course, I will use red and black. Um, so this goes there, plug in this. 1 and 2 will come in on this side, and then our positive and negative will be over on this side of the receiver. But we're getting really close here. It is 9:18. What I will do is go ahead and complete the wiring um, for the receiver and get this pigtail ready so that when we come back on next stream, we can go ahead and install our batteries. We'll get this zip tied down and we'll do our final wiring, and then we'll start into doing the programming because we have to program the Arduino, we have to program the Nano, and then it will be trying to put it in the cradle and see if we can't get movement going, right? So a little bit more wiring to go, not a lot. We're getting close to done on this. So a couple more streams and we should have a working, functioning Dio droid. But no worries, Westry. I was just seeing where you were on the project because I know that you had some setbacks with the house and stuff. So I wanted to make sure that you were still good and able to work on it and you didn't have any major issues. Um, Trust me, I know all about having projects that still need to be finished and worked on, partly so that I can make more room around the shop for new projects. So let me get that put away for the time being. So, folks, with that, I think we've made some good progress today. Once again, the um, the Dragon Den workbench is a bloody mess, but we've made a lot of good progress. Right, we've got our electronics pretty much all put together. Well, we've got our electronics sorted to include updating the wiring for our head box. And so once again, this is going to plug in. This will connect to this front piece. We'll have our wheels on, and we're starting to look like a droid. So we've made good progress. I still need to do some soldering, so um, I will fix the soldering for the top part where we switched our gauge wire gauge out. Um, we need to solder the terminals on the batteries so we can install the batteries. Yeah, so a few things, and I'm going to do that stuff off stream just because watching me long distance try and solder, I don't think that's a good show. I don't know. Um, but yeah, so that's kind of where we're at. Come over here, folks. Thank you so much for hanging out with me tonight. Um, as I've mentioned a couple of times, it's been a really long and rough week. Thank you for coming and sharing your time with me. Um, it means a lot to me that you guys like to come out and hang out with me and chat amongst yourselves when I'm head down trying to focus on a wiring job or something. But we're continuing, I hope, to do cool things that everybody likes, both in 3D printer builds as well as starting to do some other cool projects. So hopefully you guys are really digging this. We've got a couple of droid builds to do. We've got a couple of battle bots to do. So, I think we're going to have some interesting things of 3D printed things that we are doing project wise, as well as actual 3D print. So, thank you all so much for being here. Let's go ahead and see who we have for a potential raid target. Um, so the little raid icon in my interface really give me. Let's go back to Twitch and see who's there. Britt is on. Got somebody today, or is she doing 3DP Easter Bilby Prophet DNA is on doing Gun PLA with friends. So he's got AZ Pinoy, More, and ArcFox. Science is on. Crafters on. Dying. What sounds good to everybody? Yeah, not a problem, Mr. Wiz. That's my biggest thing is I like giving back and I like sharing. So this right here is great, and this just helps me deal with some of the other stresses. Dinner, you got to go eat. Hey, I understand that, Urban Monkey. Go feed the belly. I got to do the same thing. Um, let's yeah, Brit or AZN gang. Um, it's up to you. I'm gonna peek into. Ooh, I know. We're gonna snooze the ad because we're gonna try and drop out. Um, kind of looking real fast. There we go. All right, I'm going to set up the raid over to Brit. There we go. And let's go over and hang out with Creatix Brit and watch the little build that she's got going on. She's always talking, printing, and building. So let's go over and say hi. Thanks again, everybody, for being here. And we will see you on Saturday as we get back over on the Trident build. Have a good one, everybody.